Hi everyone. I'd like to talk about the tally and Venn diagrams that we did during the academic year meeting. So we took a tally of the class and we saw that 12 of the teachers have at some point in their career taught Algebra 1, 10 had taught geometry, 3 had taught neither, and the total number of teachers in the room was 17. So my question to you was, if you randomly chose a teacher in the room, what is the probability that that teacher has taught both Algebra 1 and geometry? So you are asked to model the situation using a Venn diagram. Now we know that the total is equal to 17, so there were 17 teachers in the room, and we knew that 3 of them taught neither algebra nor geometry. However, we want to know how many teachers, in order to figure out the probability, we have to know how many teachers taught both. We know that 12 teachers, I'll just put a little 12 up here, taught algebra, and 10 people taught geometry. And we know that there has to be teachers who taught both in the intersection, because when we add 12 plus 10 plus 3, which is 25, that's much greater than the total, which was 17. So we can use guess and check, and Devon showed that during class. However, if we want to actually look at the counts, we can think about the number of people in algebra. If I represent that as this circle, the black one, the number of people who taught geometry as the orange, okay? And if I add them together, what I have is the intersection, but as you can see, the intersection was counted twice. So in order to get the number of people who taught either algebra or geometry, in other words, the union, you can take the number of people who taught algebra plus the number of people who taught geometry, but then you have to subtract the number of people, the middle, the intersection, the people who taught both algebra and geometry. So we're going to write that as Melvin had said during class. The count, the number of people in algebra, plus the number of people in geometry, minus the number of people in algebra and geometry, because that is the intersection and it was counted twice, and that's going to be the union, the number of people in either algebra or geometry. So what we want to do is figure out what goes in the intersection here, so we're just going to isolate that. Okay, and then we get the number of people in algebra plus the number of people in geometry minus the number of people in algebra or geometry. So we know that the number of people in algebra was 12, the number of people in geometry was 10. How do we figure out what was in the union? Well, we know the total was 17. 3 taught neither, and therefore there has to be 14 who taught either algebra or geometry. And if I add and subtract, I get 8, which is again the number of people in the intersection. So therefore, if I put an 8 here, I know there's 12 in the entire set, then that of course leaves us 4 who taught only algebra, and here there's 8 but 10 total, so there were 2 who taught only geometry. And therefore the probability, if you randomly choose a person in the room during that meeting, then that would be 8 out of the total number of people, which was 17. So this is a little bit less than half. So you have a little less than half chance that you pick someone who taught both algebra and geometry. Okay, I hope that helps clarify what the discussion from the academic year meeting. Thanks a lot. Bye.